These are the Module 10 notes, conditional probability, page 2. So we are going to just briefly touch on Bayes' theorem. Bayes' theorem gives us the opportunity to find the probability of an event based on stuff we know about the way things happen individually, based on stuff we know about the way things happened previously. So here is what it looks like, and this is more an effort to make sure you understand how to work with the formulas than anything else. So we've got the probability of A given B equals the probability of B given A times the probability of A all over the probability of B. So example 2 sets this up with probabilities given for you. So I'm going to write the formula first. We want to find the probability of A given B. That is going to equal the probability of B given A times the probability of A all over the probability of B. I always remember that on the top it's B given A and the other probability is the given part. So we've got the probability of B given A is 0.88. The probability of A is 0.63. The probability of B is 0.77. When we multiply the top two and divide by that denominator, we get a probability of 0.72. Okay. So now we're going to do this with our example of rolling 2 dice. Okay. So Michael rolls 2 fair dice, numbered from 1 to 6, records the results. A is the event of rolling 2 numbers whose product is a square number. So when we talk about a square number, we're talking about a number times itself, or the square is the number that can be factored into something times itself. So the probability of A, let's see, A is the event of rolling 2 numbers whose product is a square number. So 1 times 1 gives us 1, 2 times 2 gives us 4, 3 times 3 is 9. We got 16, 25, and 36. Those are our squared numbers. There was no way to multiply 2 of these to get 1, so I don't have to worry about that. The second one, though, 2 times 2 is 4. So I can also get that multiplying 1 times 4 or 4 times 1. That's the only other way to multiply and get 4. So we've got 3 times 3, which is 9. No other way to multiply to get that. 4 times 4 is 16. Only other thing we could do is 2 times 8, and we don't have that option. And 5 times 5 and 6 times 6 are also out of there. So probability that we roll a product that is a perfect square is the 8 that we have divided by the 36 total. And I'm not a big fan of complex fractions, and fractions, so we are going to go ahead and convert this to a decimal, 0.22. B. B is the event that we're rolling 2 numbers that are even. So let's see if I can go halfway. 2, 2, 2, 4, 2, 6. I can skip the odd columns. I got 4, 2. Let me go place that one. 4, 4, 4, 6, 6, 2, 6, 4, and 6, 6. So I've got probability both even is 9 out of 36. And when we divide that, we get a 0.25 probability. So we want the probability of A given B. Probability that we roll a perfect square given that we roll two evens. So I start with the given part, both even. There were 9 ways to roll two even numbers. Out of those, the 2, 2, 4, 4, and 6, 6 also satisfy A. So 3 out of 9, which gives us a 0.33. So the probability of B given A is going to be the probability of A given B times that probability of B, last thing I wrote, all over the probability of A. I have made sure that everything here is labeled so I can easily find my numbers. And when we multiply 0.33 times 0.25 and then divide by 0.22, we get 0.375. And the last one we are going to make go away. We are not going to view it in terms of that notation. And there is page 2.